In this video, we'll illustrate an add-in that Riffin has developed for JMP. This add-in allows you to extract experimental data directly from Riffin and automatically join that data together across processes. So first, we will open Riffin Help and download the add-in. You'll find the add-in in the Analysis section of Riffin Help under Download RiffynTools. We'll click the link to download it and simply click or double click the add-in to install it into your copy of JMP. Once you've installed it, it will show here on the menu, and to run the add-in component for extracting data, you just select the Get Experiment Process Data Tables via Riffin menu item. This opens a window here where you enter your credentials and the ID of the process and or experiment and process IDs list to select selected processes out of Riffin or selected experiments. You also have options to join the resulting data tables together using different joining methods. So let's show you that with two examples, one simple and one a little more complicated. So we'll go to our process library, and in the library we have two processes here, a simple fermentation and a capillary assay. So we'll open both of those up, and we'll see that on these processes, the first one, this fermentation, is a fairly typical fermentation, seed culture, batch fermentation. Take some samples and then measure the optical density and HPLC of the cell culture samples taken from the fermentation. Now, you may also decide later that you want to run additional assays, such as this capillary DSP assay. However, if you run this as a process, this process separately as an experiment, it won't be automatically linked in with this fermentation process, even if you use the samples that were output from the sampling step as inputs to this process. You need a method to automatically connect those, and this is what the JMP add-in does. So if we open the experiment on these two processes, we'll see that. We'll see that the outputs of the fermentation process are actually inputs to the capillary process. So we look at the take samples process and we see these samples here, Bro 170816-0-1, etc. And if we look at this experiment, we'll see those same samples as inputs to the experiment on the assay. That means that the outputs of the one process are feeding into the next, and we can use this new tool to automatically connect the resulting experiment. So going back to the process library, we'll create a new process, and this process will allow us to link those two processes together. So we're going to choose Link Existing, and we're going to find the fermentation and then the capillary process and link it into this. So here we have the fermentation. We'll link that in. And then we'll do the capillary process. And link that in. And we'll just connect the two together. Remove the irrelevant step. And now we have the fermentation process and the capillary process connected together by the cell culture. Of course, there's no experiments on this, but that doesn't matter. This process is simply being used as a template instructing the add-in how outputs of one process are being fed into the other. So we grab the idea of this process, and then we switch back to the JMP add-in, and we're going to enter that as the master process ID. This is that overall process that provides the linking instructions. We'll enter our credentials, and we're going to select join because we want it to fetch the data and then connect it together. A left join is fine. We'll save those credentials and click OK. This activates the API. It goes out to the API and collects the data, and then produces the data tables, one for the capillary and one for the fermentation, and then joins it together. And you can see in this data table, if we expand it, that the columns that we have in this join data table include both the fermentation columns and the capillary columns, and they're joined on the cell culture resource identifiers in the output of the fermentation. So we can see this is the column that is used, and these identifiers are used to connect the two data sets. And we have 153 resulting rows in this table. So that's the basic idea. You now have the ability to look across any variables from fermentation all the way to the capillary assay, all connected together so you can understand cause and effect. Now let's take a more complex example. we also point out you still have the individual data tables from the two processes. But we're going to take a more complex example. So let's now look at a process that was developed by Delft University. And it's this one here, an overview of a bioreactor process. So we'll open that. And we'll also go back to our process library and back to the library and open the experiments page. And we're going to look for the Delft experiments. So these are the Delft experiments. We actually want this one here. I'm going to grab the name of the experiment and search for that. So what you're going to see here is that we've got a set of experiments similarly named across multiple different processes. These individual processes are actually all linked up according to this master process. So we have the synthetic medium preparation, the bioreactor preparation, batch cultivation, dry weight, metabolite analysis, and optical density analysis, as well as others. So we can do what we did before, entering the process ID for this overall process to fetch the experiments, and we can fetch all experiments on these underlying linked processes, or we can fetch just a subset. So we go back to JMP again, and we run the AddIn. And this time, instead of getting all the experiments on those sub-processes, we just want to take a subset. We want to take, actually we'll just copy it here, take that one experiment named with that one name across all these different Riffin experiments, and we're going to enter the name of that, and it will fetch only the experiments matching this name. And again, we want to join these data tables together, and we click OK. And now it's going to go fetch all those experiments. There's 6 of them. And then when it has retrieved all of them, it will again do the join, connecting everything according to the linking information saved in this overview process that we see underneath JMP. Just give this a minute. There's our 6 process data tables, all corresponding to this one experiment because we restricted it to that. And now the join data. Here we have 13,252 rows in the join data table, crossing from all the process steps: batch cultivation, dry weight analysis, optical density measurement, the HPLC measurements, the bioreactor preparation steps, and the synthetic media preparation, meaning that you can correlate variables from any of these process steps against each other now in this joint data table. Another nice thing about this add-in is that if you felt that you didn't get the right join of your data, you can go back without retrieving the data again and just say use existing data tables and try a different join. So we could, for example, try an inner join or an outer join. Let's try one of these. I think we get the same result, but even with a different joining method. So this doesn't fetch the data because we already have it. It just tries a different join. And in this case, yes, we got the same result. So it didn't make any difference, but sometimes it does. So that concludes our demonstration.